stateless allows home and temp directory to be read and write. So we can able to create or delete a files in this directories. So if app having permission to access home directories, it can, for example, steal your SSH keys and perform some malicious operations. So stateless systems are not highly secure. So and this usage. Um, Suppose if we make frequent changes to the file systems, we have to lot of snapshots will be created, so it consumes a lot of space in disk space. And reproducibility might have built every dependency from source. So as we are developers, we are often developing many softwares. We will change some source daily, so lot of changes happening. So in those scenarios, dependencies will be built often. So it consumes a lot of space. So to avoid this, we can use shared libraries. So two or more projects having the same library as dependency, we can use that library for multiple projects. Next, bandwidth. So in reproducible system, we have to download a lot of dependencies. So every time we build the project, we have to build a lot of dependencies. To overcome this situation, we can use the local mirror, where recently built packages are available in the local mirror. To use it, we can just get it from the local mirror. And as I said earlier, every dependency has to be built from the ground up every time. So if you make a simple change, we have to build it from the ground up. So it increases build time.
So usage perspective. So you might be asking, what's the need for immutability for me? So what is it going to give me apart from the conventional operating system? So let us see some perspective of how it can be helpful for you. So first, as a developer, so as Ragul said, we all will be working in different projects, and each of the projects might have a different set of versions and dependencies. So when I'm in a team, I want each one of my team member to have the same set of dependencies as mine, so that the problem of that this work on my computer gets solved. So for this, a declarative system helps us a lot. So where we pinpoint the exact versions and the nested dependencies. So this file I can share it with anyone, and I can ensure that every one of us has the same environment as mine. So it will be easy and helpful in developing the software. Next, as a system administrator, even maintaining a single server as a system administrator is very, very difficult task. So for this, what we can do is a declarative configuration list is a single text file. So this text file can be shared across multiple systems, and the systems we can automate them, and using this automation we can install the same configuration in every one of them. And regarding the vulnerabilities, since the version numbers are just explicitly mentioned in the text file, we can just use a static linter or analysis tool on whatever it is, and to track the dependencies and see if there is a vulnerability present in them. Then third is the replication. So suppose you're having hundreds of servers and you want to replicate the same system in every one of them, then this declarative system will be helpful for them. Then at last, snapshots. So suppose you're shipping some buggy application or malicious or whatever it is not working good, then it can revert back to the snapshot that was working well. Next, as a normal user. So this, for me, normal user is someone who is not much into technical things, who is scared of terminals. So someone who is very, very new to this. You can see an average Windows user maybe. So for them, what's the advantage? The immutable file system or immutable OS gives us that. It gives them freedom to play around with the operating system. So suppose if I'm having a operating system, then I want to do something, means I want to install a package. Then I have a fear in my heart that, okay, if I'm installing this one, it might break my system. It can do something which I'm not sure it will work properly or not. So what this immutable thing will do is that I can make any changes as of my free will, but if the change is not something good or it's destructive, then I can just simply revert back to the previous snapshot. So this is one thing, something good. Then second is in terms of atomicity. Unlike a server system, we can't guarantee when SSDs or things, power failures might happen. So for a person who is in a remote area where this power supply is not consistent, for them, atomicity can ensure that their update or whatever is happening doesn't leave the system in an inconsistent state. Now, let's see some inspiration for the existing technology. As I said, this immutability thing, it's not a new concept. It's being used currently in many things. So let's see one by one what. So first is libOS3. So libOS3, it's popularly known as OS3. So it's in the website they're saying it is a system for versioning updates, but popularly we call it for Git for operating system binaries. We all know Git we use for version management, but Git is optimized for text files. But this OST is optimized for binaries. Okay. So this OST is very similar to Git, but it applies for the entire file system. So the underlying thing about OST is that the advantage is that whatever changes you're doing, it results in an entry in a bootloader, so that you can just use your, when you restart your computer, you can just go to that entry you want, and it gives you the operating system, means the file system at that particular moment in time. Okay. So this libOS tree is being used by Endless OS, Flatpak, and Fedora's immutable scenes, which includes Fedora, Kionite, and Silverblue, etc. So overview, suppose you're using libOS tree, how you will be able to use it. First of all, you create a new repository, just like in Git. Then you just make changes, but instead of in Git, you make changes to the entire OS. Then you use OST to commit it. Then after that, we deploy the new commit. Then after that, if the changes is something not you wanted, then we can revert back. So let's see a quick intro of how this means. So first, you have to install OST. Since OST is available in Debian repos, just it's an apt install away. And after that, you create a repository. So I'm creating a repo called a repo. Then you make a working tree. So working tree is the place where you're going to store the files you want to keep track of. After that, you make the changes. So I'm giving a simple Python's inbuilt HTTP server. I'm using that, and I'm storing that file in tree/server/app.sh file. Okay. Then after that, I'm committing it. You can see here in the commit thing, I'm committing the repository named repo, and the branch is main, just like in Git, and the subject is I'm created server. So it gives him a SHA-256, which identifies the commit. After that, I'm making changes to the changes, as in I'm updating the file change. Now I'm adding a new line. I'm preparing a new line called echo running. So, and then I'm committing it as subject added logging. So this gives him a new commit, which identifies this new commit. Now let's see the commit we have made. So for this, I'm using OST repo log main. So it lists all the changes that has been made in the branch main. So you can see the commits and the parent commit and the subject of the commit here. Just like in Git, you can identify commit by using the minimal number of required characters from the beginning, as you'll see in the next thing. So suppose you want to list the files in a branch, then you can use this command ls, which is list the files in a particular branch. So our branch main has a folder called server, so it listing it. Then if you want to view the files available in a branch main or at a commit, then you can use cat. So just like in the normal cat thing, it gives you the file. So I'm just for concatenating the files in main. So main means it gives the latest file in the latest commit. So there you can see echo running and python 3m http.server. Then I'm concatenating the file in commit 9b752. That's also same. Then I'm going back to the previous commit. It is 5891b. You can see here. It's a first commit we made, 5891b, this created server. So if I want to view the file at that particular moment, then I can use this concatenate, and it gives me python 3m http.server. Now let's see. Suppose you make some destructive changes or changes malicious things. So yes, I'm just changing the http.server to ftp.server. If you know, there is nothing. HTTP server is a built-in thing in Python, but there is no ftp.server. So this is an NS change, and I'm committing it as update to the FTP tree. Okay, now I'm checking the logs again. This change has been committed, and now we are going to revert it back. So to roll back to that, what I'm doing is that I'm using reset main, means the branch main, and I'm resending it to the commit called 9b. So the 9b thing, you can see here, it is the added logging that commit. So I'm reverting it to that one. Now I'm logging it back. You can see that commit we made updated to FTP server. It's completely wiped off. Means it's no longer present in the history. So our means our OST has reverted back the files. Now I have to deploy the files back. So OST has deleted the commit. Now I have to ask OST to deploy the commit to my file system. So first, before running the deploy, you can see here the file is echo running and python 3m ftp.server. So now I'm checking out that commit. So what this union thing does is that it merges the files in your work, in the OST with your working in your working tree. So it merges the files, and I'm merging checking out the commit called 9b752. And after that, I'm concatenating it again, and you can see it is python 3m http.server. Now, suppose you want to pack the changes made to in a branch, then you want to export it. Then you can use this export command, which exports as a tar archive. And this, you can see it contains all the files available inside it.
So this is the basic setup of how we might be using libost. Now let's see some advantages and disadvantages of it. So first of all, OS3, it's designed for the very purpose of immutability. So as a Unix mantra, we can say we are supposed to use the right tool for the right thing. So libOS3 is the right tool for the thing of immutability, snapshots, and commits, and everything. Then next is similarity to Git. So most of the terms and things are happening libOS3 is very similar to Git. So if you're knowing Git, then libOS3 is almost 90%, it's already known to you. Then, these people who develop libOS3 or consider all the setups and different setups it might be having in a professional working environment, and they consider this and they made this built-in functions. So most of the setups and things you need is already built in them. But the demerits are that it is not meant for direct end-user usage. So what this libOS3 does is that, as you can see the name, it's a library. So you're not supposed to use it directly. Just for demonstration, or you can say, I think they're giving a command line, but you have supposed to, your Debian or like Debian's operating system, then apt or something, it should be integrated with libOS3. As an end user, we are not supposed to make the changes, commits and all. It's apt or Debian should be able to do that automatically on its own. Next is lack of much documentation. So this thing is, even during while preparing the slides, I faced this issue. This documentation for this OS3 is very, very less. Outside the official ones, there are not much pretty tutorials about it. So it can be a showstopper for you if you're looking for other documentations. Next is needs non-trivial changes for usage. This libOS3 can't be adapted to an existing system as it is. This existing system has to be, changes has to be made, as in case of like a package has to be made read-only and other things. So for this, we need non-trivial changes. Next is Fedora Silverblue. Fedora Silverblue uses RPM OS3, which bridges RPM, which is a Red Hat package manager with this OS3 thing. So it uses OS3 underneath. So it is an immutable variant of Fedora Workstation. So Fedora Silverblue provides 3 methods of installing OSes. So it is Flatpak, which is for GUI apps, and toolbacks for the CLI apps, and package layering, which is RPM OS3 to install core applications like drivers and other essential packages. So these are some commands. To upgrade the OS, you use RPM OS3 upgrade, and to roll back, you simply use RPM OS3 rollback. The advantage is, as I said, it uses libOS3 underneath, so that the user may not be aware of the libOS3 things at all. So Fedora takes care of everything for them, and it deploys a simple GUI and all of the advantages of libOS3. The demerits is that development in Fedora Silverblue can be difficult, because since the file system is read-only, most of the packages has to be changed to make sure it adapts to the OS2 thing. So this, and for Guix.
So next, we will see about Guix and Guix, which are the package managers, and there are also systems available, but we will see about package managers. Guix is widely used in Guix OS operating systems. It's a package manager where we declare every dependencies in a shell.nix file, and we can create an ad hoc environments. So this is just an installation. So what we can do with Guix, we can prepare a declaration and spin up the environment, and we can update the environment. So to install the environment, we can just simply give this command, next nv install Python. This will install this Python 3 package in an environment. So if we install every packages, it will create a generation. Generation is nothing but the set of packages available at a particular moment. So this will, one can have multiple profiles. Profile is nothing but a collection of packages available for use at that particular time. So we can see if Python 3 is not installed on your system and you install it using Guix nv install Python 3, it will be there in Guix/store with hash generator to it. So we can see the path where the Python 3 is installed here. So to uninstall a package is pretty much easy. Just give uninstall command. So similar to libOS3 and Fedora Silverblue, we can switch between generations. As I said, if any error happens, anything, we can switch to the previous generations where the packages are working correctly. So here we install Python, and in the next generation we have installed a tree program which lists the directories and files in the current working directory. So if we switch to the previous generation by using switch generation equal to 1, we will be kept back to the first generation where the tree program is not installed. So if we run the command tree, we will get the command not found. This is packages available in the one generation doesn't affect the another. So to make a reproducible environment, we can create a file called shell.nix where we declare the dependencies of that we needed for a particular project. So we can share it with others. So they can make the completely reproducible environment. So without shell.nix, we can create an ad hoc environment using -p Python. So Python will be available only for that particular shell. So this is reproducible environment. Here we are making make shell and we want to declare Python, Flask and curl. We are going to for developing a Flask application. This make shell function creates a shell where the defined packages are available. So we can create to a version controlling system and we can share with our co-developers so they can create a completely reproducible environment from this. Similar to Nix, there is GNU version of it, it's called Guix. So most of the commands and functionalities are one and the same. So, but advantages is that packages built with Guix can be used by the one systems where Guix are not available. But in Nix, it can't be do that. So we can just install the Guix as a package manager. It's available in Debian repositories. So it's like Nix. Guix shell Python 3 creates an ad hoc environment where the Python 3 is available. This is similar to Nix. It creates a hash and stores this Python 3 in GNU/2. Similar to Nix, it creates an ad hoc environment using Python and NumPy. In that particular shell, these packages are available to use. Next, the main advantage of Guix is that if we pack our application into multiple targets like Debian means .deb file and RPM files, we can issue a simple command. This command packs our application into a .deb file. So we can give instead of deb, we can give RPM so that we can create Debian archive and RPM archive using the simple command. This is the biggest advantage of Guix. And once we export our application, it can be used by systems where Guix are not available. Next, cget-shoot. So immutable system or temporary directory which can act as root, we can make that using cget-shoot command. It's available. So, but it's not a solution to make a reproducible or immutable environment because we have to perform some operations like installing packages and removing things. So for this to work, we have to move some programs from our local system to that particular directory. So for this, we can use debootstrap, which can automate this process. But we have to keep track of several directories to have multiple versions installed. It's a tedious task. So let's do a simple experiment. So what if apt will behave like Nix? So what will happen and how Debian could be like? So if apt have the ability to work like Nix, so it means it won't affect the environment. It installs the package in a particular directory. What can be? So in this, it's like a hypothetical experiment. In this, we installing a Python 3 in a directory called foo. So the Python 3 is not installed in a standard location. It will be installed in the directory specified. So if we are developing a package where we can install all the dependencies for a particular application. So in such scenario, when we build an application, apt or any other build tools will only look for the packages in that particular directory. If the packages are not available, it will be fetched in the standard location. This by using this approach, we can have isolation environment. Means the source files and the dependencies are present in the same directory. So we can have get complete control over the dependencies. And snapshot. So every change in packages can result in a new snapshot, as we said earlier. So libOS3 library might be needed at some point for compression and differential storage. And next comes the existing concepts like BTRFS is file system, where if any changes occurs to the files, it will be copied. So it has support for subvolumes with different properties like permissions and quota. And next comes Flatpak. It's also built on top of libOS3. Applications will be installed and run in a sandbox environment where we have to provide explicit permissions to, for everything. So if it, as it's running in the sandbox, it doesn't affect the host environment. Next comes containers. So container tools like Docker, Podman can be used to create a lightweight virtual machines where the running process won't affect the host environments and it doesn't depend on the host environments. So next will be presented by him.
So now we've seen that. So the thing about this, why we introduced this talk is that, let me present a small story about it. So I had to compile Fosh on my Debian system. So for this, I had to install a lot of packages. So as someone who is who wants to keep the number of packages minimal, you can call it OCD or something, but I always say this package I'm installing, it must be surely used by me, and it should not be like, I should not have this thing called, okay, it's being installed unnecessarily. So for this, when I was trying to install this first thing, it listed a lot of dependencies. So I had the fear, okay, this is having a lot of dependencies. Surely we might be, we should have to use it or not. So I had this thought. So for this only, if the app can install to a particular directory, just like in npm or node module or something like that, only inside the directory that the package is available, then this will be isolated from the entire system, as in that my system will be working as it is, and this package is only will be inside the directory of my console. So I can do whatever I want with them without affecting my environment. So this is the need for the thing from my perspective, I thought. So suppose you're also interested, okay, these things are good, okay, Nix, Guix, they're getting popular these days. So you're also interested. So what approach can you follow? So this is some opinionated guide I'm suggesting. So first for development, so you're a developer, you're working on something, then I can say that Nix and Guix are pretty good for you to start, because you can use them to create an isolated environment where only the packages you need are installed, okay? There is a flag called pure in both Nix and Guix. What it does is that it completely makes sure that none of the dependencies are from the host OS. Means every dependency has to be explicitly mentioned, installed by you in that folder. So Nix and Guix gives you that much freedom. So this gives a completely isolated environment. This isolated is for you to play around, and it won't hurt your operating system or things in any way. So as for development purpose, you can use Nix, and for this, you can use this to package into a deb file or something like that. Next, for deployment. So coming to the point of deployment, here containers can be pretty much useful here. Like since we saw on the last slide, containers of lightweight virtual machines. So what you can do is that you can just use a Debian as a base image in the container, and you can ship your application inside it. So this makes that in a server, you will have multiple containers, each with its own set of dependencies, and this dependencies won't be affecting other dependencies or the host system dependencies. So this can be a pretty much good start if you're looking into this thing. Next is conclusion. So when we prepared this talk and when we told this to many few people we met here, they were like, we in Debian always love packages to be installed from the official Debian repository. So when you're saying that if you're going to use Nix and you're going to suggest Nix, then it's going to be controversial because you're not going to install from some third party, because we always love and trust our Debian maintainers than any other person does. I think I'm right in this thing. So for this, I can say this talk worked on a computer. Means as we said, we are students of an university. So what we do there is that we have a server, and in the server we follow the same approach, and it has been working pretty much good there. So what we do is that we package all our applications into containers, and these containers are isolated, and using this we can pretty much start and commit the containers at any point. It gives us complete freedom without worrying about what if this package breaks another package, something like that. And at last, no Debian packages were hurt in making this presentation. Thank you all.
Thank you.
Yes, thank you very much for your very nice talk. The room is packed full of people. I'm sure there will be lots of questions. Just raise your hand and I will bring the microphone to you. If not, I can maybe start.
Yes.
I've been doing things, so what would you say would be the preferred way forward to making immutable images work on Debian? I mean, I have an interest in this, and I know that like the GNOME people have a lot of interest in this for mobile phones.
So the thing is that Debian, you can see it's a conventional distro with a lot of philosophies on the consideration followed since past, like etc. /var directory, something like that. So if you're going to make an make the Debian thing as immutable, then it needs a lot of changes, as that we might need a complete derivative of it itself. So it starts with making the entire file system as read-only first of all. Then we have to make this /var and /temp and home as read-write, and we need to make sure that packages installed via apt or anything, it gets properly recorded, as in it's made in a snapshot. So these are the first things we can start. Then once this going pretty much good, then we have to make sure that these things are properly configurable from the bootloader as well. As in once you open your switch on your computer, you may be able to see the list of snapshot available, and you might be able to go into that particular history moment of particular snapshot is from the bootloader. So this needs some non-trivial changes first of all, and it breaks our user perspective in a lot of ways, because we always believe that our operating system should be able to modify in any way, give complete freedom. But this breaks our assumption a lot, so this needs a lot of steps actually. But think endless OS, it's a Debian derivative, but they're doing this thing. But what they're doing is that they're restricting themselves to Flatpak. They're giving us strict guidelines. Okay, you're supposed to use this one, then only can guarantee immutability. If you're going in the other way, then no, you're not going to do anything. So we have to also impose such restrictions. So this might need some lot of time to come over with. Yes.
Can I ask? Yeah. Hello, can I ask a question? Yeah.
Yes.
Yeah. Okay. How better? Yeah. Yeah. So if you are, I mean, all right. Do I have to kiss it? Yeah. Right. So if suppose there are two applications using the same program, so one application uses an older version, and the other one uses a newer version of the library. So if you are installing it if you are installing like Guix, they use checksums, right? Something hashes or something. So does that mean that we have to install both, and there will be, if that is like that, and if we are using a lot of libraries, doesn't that mean that the size of the installed thing would be very large compared to the usual thing?
Yes, yes. Yeah. So as we see in issues in, just let me go back to the slide. You can see here. Wait. So you can see disk usage. It's a disadvantage you're currently facing. As you said, in Guix, what happens is that every package you install, if it's the same, it gets shared. Otherwise, it has to be installed again. So if you're having 10 versions of the same library, then all the 10 versions has to be installed. So this we can't consider this a disadvantage, because you surely need it. So since you're explicitly depending on that library of different versions, then you have to install it surely. So there is no other way to go. But if the same library means same versions means, then there's Guix and Guix have provisions for that they share the libraries. So since they're storing it in the same root directory and it's a /Guix or store, so they will be shared. So when the library versions are same, then they'll be used shared. Otherwise, we have to install them. The disk usage thing is there, yes.
I would have another question. I think one of the reasons, I have to eat it. One of the reasons for immutability is also to have secure boot enabled, so that you can build a static chain of trust from the firmware to the OS beyond maybe the kernel, which is kind of immutable usually. Have you looked into that as well? So the aspects, for example, how we build init RAMFS in the future, which could then be statical and immutable as well. Obviously, they are already, but they have to be checksummed, they have to be signed. That's also an aspect of that. Is this something you looked into as well, or is this not in scope for it?
Yes, so the checksum thing is a part of this, we said the declarative configuration. So checksum thing is also part of it. So every package needs a checksum thing. So as you said, we need a tamper-proof environment. We need to build the level of trust from the kernel level itself. So for this checksum thing is helpful, and we also have this new things called TPM and etc., which also helps us in this regard. So maybe we can do something in that regard, as saying like a kernel package, we can ensure that it's the same thing we downloaded, but to build a level of trust, we might need more support from the hardware side also. So Nix or Guix, they don't cover it, but maybe if you're going to do this in Debian, then we can look into it, see how it can be done.
So have you considered using OverlayFS, for example, for allowing for system packages, since that way you could, for example, make your user directory immutable, and then you could mount the overlay somewhere else, and then you can install system packages to that. So that would allow for atomic updates and atomic package installation aside from immutability. So yeah, have you considered that?
Yeah, you're talking about the OverlayFS, right?
Yeah.
Okay, so yeah, the thing is that with the OverlayFS, it's another file system. So we just know, means the technologies are there. So what we are doing is that we are directly using libOSes. So libOSes is transparent, means it completely abstracts with the file system using. So if you're having an underlying file system XTR4 or BTRFS or ZFS, then it makes sure that it adapts to the technology or means the file system you're using. So you can also go with the, means what you can say, from scratch you can build your own immutable file system from using OverlayFS. But the thing is that once you cross the limit, you have to make sure of security and the management to optimize it and these things. So at this stage, you're just reinventing the wheel. So this wheel we are reinventing is libOST. So OverlayFS, I think libOST, if it is installed, it can adapt to it. But in the website, they're saying that it is completely abstracted file system. So it makes sure that whatever file system you're using under it, libOST adapts to it.
All right, because for example, for CentOS, what we do is we have a root file system, backstrapped on Arch Linux. So on top of that, you have a bunch of user overlays, for example, that you can install packages to. So we have a tool for that, so you can just on system install a package, for example. So then on the next boot, it applies a package. So you have an overlay for that. You have an overlay for all of those directories. And then there's a central tool that manages all of that. So we went for that since it was comparatively simpler. I mean, if you consider the complexity of OSG. So I was thinking of, using some sort of approach of that sort for Debian. So yeah, that was why I asked that question. But yeah.
Any other questions in this room? Otherwise, there were a few questions on IRC. Okay. So Bluecar is asking, on immutable systems based on DDYs, so discoverable disk images with signed DM verify, trust is established before loading via cryptographic signatures enforced by the kernel, so that even root cannot subvert it. Does libOS3 provide similar functionalities?
Can you repeat the question? I'm not able to.
It's a long question, but okay. On immutable systems based on discoverable disk images with signed trust, or trust is established before loading the cryptographic signatures enforced by the kernel, so that not even root can subvert them. Does libOS3 provide similar capabilities?
Okay, so the thing is that libOS3, it maintains this, it's a bridge between your package manager and your file system. So libOS3 doesn't on its own provide any way to ensure the packages you're downloading and check some things. It doesn't interfere with it anyway. As we saw in the demo setup, as I shown in the overview, or like you make the changes and you tell libOS3 to do that. So if we need something to for the libOS3 to ensure the packages you're downloading and using, they are consistent, the checksum is verified. So it has to be done by the package manager, as it is being done in Fedora Silverblue. That they're using RPM OS3. This RPM takes care of all this checksum things, verifying and all the authenticity things, and RPM instructs the OS3 to do the commits. So it's not the job of OS3. but it has to be run from the apt or other package manager you're supposed to use, you're going to use.
Okay, thank you very much for your very, very interesting talk. Let's have another round of applause for Arun and Ragul.
Thank you.